Welcome to The Explainer. Today, we're diving into a delicious little puzzle that honestly seems to break the rules of basic math. And it all started with a simple pizza night. So let's start with a real head-scratcher. How is it even possible that 4/6 of something could be more than 5/6 of it? I mean, everything we learned in school tells us that 5 is bigger than 4, so 5/6 has to be bigger, right? It just feels wrong.
Okay, so let's meet Muthika and Mitansh. Their pizza night is what created this whole paradox. She ate 4 out of 6 slices. He ate 5 out of 6. Simple enough. But she actually ate more pizza. So how on earth did that happen? Let's figure it out.
Okay, let's break this puzzle down piece by piece and see exactly why our first gut reaction, our intuition, can get this so wrong. You know, when we see fractions like this, just shown as diagrams, our brain does something automatically. It compares the shaded areas and just goes, yep, 5/6 is definitely bigger than 4/6. And if you're only comparing the numbers themselves, you're absolutely right. And yet, here's the reality of the situation. Muthika, who ate the smaller fraction, somehow ended up with more actual pizza. It's kind of like putting a smaller number on a scale and watching it slam down. It just doesn't compute, and it means there's something we're missing. So what's the secret here? What's the trick? Well, it turns out it's incredibly simple, and once you see it, it changes the entire way you look at the problem. And here it is. The whole paradox hinges on a single hidden assumption we all make without even realizing it. We assume that the total pizza each person started with, was the same size. But what if it wasn't? That's the key we need to unlock this. And boom, here is the reveal. Muthika didn't just have a pizza, she had a large pizza. And Mitansh? He had a small one. All of a sudden, that context just changes the entire equation, doesn't it? The second you see their starting pizzas side by side, the paradox just vanishes. It completely disappears. Because of course, 4 big slices from a giant pizza can be way more than 5 tiny slices from a personal one. The math starts making perfect sense again. Okay, so our brains get it now, we can see it visually. But let's actually run the numbers really quick just to prove it and see exactly how much bigger her pizza needed to be.
We can set this up as a really simple inequality. The amount of pizza Muthika ate is 4/6 of her total pizza, which we'll just call M. And the amount Mitansh ate is 5/6 of his total pizza, N. And we want to find out when 4/6 of M is actually greater than 5/6 of N.
And you know, a little bit of algebra makes this so much easier to see. If we just multiply both sides by 6, those denominators just cancel out. They're gone, and we're left with a much cleaner, simpler comparison. 4 times the size of Muthika's pizza has to be greater than 5 times the size of Mitansh's.
And with just one more step, we get our exact answer. Muthika's pizza, M, has to be greater than 1.25 times Mitansh's pizza, N. So, to put that in plain English, for her to have eaten more pizza despite the smaller fraction, her pizza had to be at least 25% larger than his. The math checks out perfectly.
But you know, this whole thing isn't really just about pizza. It's about a really fundamental rule of fractions and percentages that you can apply everywhere, from your personal finances to how you read the news.
And this quote just nails it, right? It's the key takeaway. You see this in business all the time. Would you rather have a tiny 1% slice of a billion-dollar company or a massive 50% slice of a company worth just a few thousand? It's the same idea when you're looking at statistics. A headline might scream that a city's park budget was cut by 10%, which sounds terrible. But if the city's total budget grew so much that the park still got more money than last year, well, that changes the story completely. It's all about the size of the pie.
This whole concept is called relative fractions, and it's such a powerful way to think. It's this little voice in your head that reminds you to always ask that crucial follow-up question. Okay, it's a fraction, but a fraction of what? You can't let numbers mislead you when the context is hidden.
So really, this simple formula is the ultimate lesson here. The actual amount, the reality of the situation is always the fraction multiplied by the size of the whole. You know, if I say I ate 50%, that means absolutely nothing until you know if I'm talking about 50% of a grape or 50% of a watermelon. Context is everything. So thinking back to the very beginning, were you able to figure out the paradox before we got to the reveal? It's such a great reminder that context is king. Numbers can tell a fascinating story, but if you don't understand the whole that they're based on, you might be getting that story completely wrong. It really makes you wonder, what other so-called paradoxes are out there that are really just a matter of hidden context?